Today, we are going to talk about heap data structure. Heap data structure is used basically for sorting and for implementing the concept of priority queues. Priority queues are simple queues, but there is a priority associated with each element. While processing these elements, we have to take the priority into consideration. There are several concepts with the help of which priority queues can be implemented, but heaps are popularly used. So what do you mean by heap data structure? Heap data structure, it is an array which can be visualized in the form of a nearly complete binary tree. So we all know what an array is. But the moment I say nearly complete binary tree, then we need to understand what it actually means. So let's see these two tree structures. When I talk about a tree structure, then it has a unique node which is known as the root of a node. So in this case, 16 is the root of this tree. Similarly, in this particular case, 4 is treated as a root node. Then they are binary trees. Binary tree we mean a node may have 0 child, 1 child, or at max 2 children. So we can verify this property for each and every node present in both the trees. At max, we have only 2 child nodes. 10 is having only 2 children, 9 and 3. 7 is having only single child 1 and 9 is having no child. So these trees, they are binary trees in itself. Then there is a concept of level associated with trees. The root node, it is present at level 0. Then we have level 1. So 14 and 10, they are present at level 1. Then 8, 7, 9, 3, they are present at level 2 and so on. Similarly, 4, it is at level 1. 1, 3, they are at level, 4 is at level 0. 1 and 3, they are at level 1. 2, 16, 9 and 10, they are at level 2. So if all the levels which are present in a binary tree, they are full, then that tree is known as complete binary tree. On the other hand, all the upper levels, they are full, and if the last level, it is filled only from left to right, then it is known as a nearly complete binary tree. So heap data structure, it follows the property of nearly complete binary tree. It is just a visualization, but the heap is actually an array. So a heap data structure, can be visualized in the form of a nearly complete binary tree. That means all the levels are full except possibly the last one, which is filled from left to right, which we have just seen. And due to this specific property, heap data structures, they are stored with the help of arrays. Because if we use linked list to implement heap data structure, then corresponding to each node, we have to maintain 2 pointers, one pointing to the left child and another pointing to the right child. And we have to store the data part also. If we follow this structure, then there will be lot of memory wastage. On the other hand, knowing the fact that heap data structure follows the property of nearly complete binary tree, we can utilize array that can be accessed with the help of their indices. There is no need to maintain any pointer memory. So we have actually saved the memory by storing heap data structure with the help of arrays. Then as we can see that heap data structure follows the property of nearly complete binary tree, and tree, that means there will be a parent node and left and right children will be there. So parent node and child node, they satisfy certain property with themselves. Accordingly, the heap can be defined in different types, which we will see later. When we talk about heap data structure, then there are certain terms which are required to be followed. So let's discuss them now. Let's say we are storing heap in an array A, and we are also assuming that the array element